Alright, lesson 1.6 was over using properties of integer exponents. So the objective was to understand properties of exponents in order to write equivalent expressions. So I'm going to go through 4 different properties of integer exponents. We're going to do 2 more in the next lesson, but we're just going to start with the first 4 for this lesson. So for example 1, that's when you're multiplying exponential expressions that have the same base. So here we have an example, the weight of a newborn male caribou is shown on the right. On average, an adult male caribou weighs up to 2 to the 6th power times more than a newborn. How can you determine the average weight of an adult male caribou? Okay, so for this problem we are multiplying our 2/6 times the original baby's weight, which is 2 to the 3rd power. Sorry, this is 2 to the 6th. So we're going to be multiplying 2 to the 3rd times 2 to the 6th. So I want us to start by writing this in expanded form. So 2 to the 3rd would be written as 2 times 2 times 2. And then I'm going to multiply that by 2 to the 6th, which is 2 times 2 times 2 times 2 times 2 times 2. Okay? So this is our 2 to the 3rd. And then this is our 2 to the 6th. So we are essentially multiplying. So this is expanded form. The second, from here, you can count how many 2's you have and figure out what the power would be. So here we have 3 and 6, so I have 9. So I can rewrite this as 2 to the 9th power. So that's the first way that you can do it. You can rewrite all of your expressions in expanded form and count them up. The second option is to use what we call the product of powers property, and that's when you're multiplying 2 powers with the same base. When you're multiplying 2 powers that have the same base, they have a base of 2, you add their exponents. So I'm going to take 3 and add that to 6 to get 2 to the 9th power. Notice we got the same answer, this way is a little quicker, and it involves using the product of powers property. So again, the product of powers property states that when you're multiplying 2 powers with the same base, you add their exponents, like here. Okay? Second property is when you're multiplying exponential expressions that have different bases. So for this problem, we're going to find the volume of cubic inches of a cube with the edge length of 2 feet. So when you're finding volume, you do whatever the side length is cubed. So in this case, 2 cubed. I want to figure out what that is in inches, and to figure out how much this is in inches, I'm going to multiply it by 12 cubed, because that's how many units are in 1 cubic foot. Okay, so I have 2 cubed times 12 cubed. So notice we're multiplying exponential expressions that have different bases. The only way you can use this rule is when you have powers that are the same. Okay, so for this one, I can rewrite this as 2 times 12 to the 3rd power, because I'm going to have 3 2's being multiplied together and 3 12's being multiplied together. You can rewrite it as 2 times 12 to the 3rd power. Okay, so for this, when I do 2 times 12 on the inside, I end up with 24 to the 3rd power. So our answer for this one would be 24 cubed. And so for this one, this is called the power of products property. And that states that when you're multiplying 2 powers with the same exponent, and different bases, you can multiply the bases and keep the exponent the same. Example 3, find the power of a power. So write an equivalent expression for 5 squared to the 4th power. So for this, I'm going to start by expanding it out, 5 squared, which would be 5 squared times 5 squared times 5 squared times 5 squared. And if you remember in our first rule that whenever you have the same bases, you can add the exponents, that same rule applies here. So I could do 5 to the 2 plus 2 plus 2 plus 2 power, which is 5 to the 8th. That's kind of the long way to do it. The shortcut is to use what we call the power of powers property. And that states that when you are trying to find the power raised to the power, like we have here, you multiply the exponent. So instead of writing all that out, I could just do 5 squared to the 4th, take these two powers here, and multiply them together. So 5 to the 8th power, since 2 times 4 gives me 8. And that's using what we call the power of powers property. The last powers property that we're going to learn today is when you're dividing exponential expressions that have the same base. So for this, we're going to start by rewriting this as a fraction. So remember, division can be written as a fraction, so I can rewrite this as 6 to the 5th power divided by 6 to the 3rd. And those are the same. I'm going to start by expanding this out. So 6 to the 5th power would be 6 times 6 times 6 times 6 times 6, all over 6 to the 3rd power, which is 6 times 6 times 6. And then we can do some simplifying here. These are going to cancel each other out because 6 divided by 6 is 1. 6 divided by 6 is 1. 6 divided by 6 is 1. So we're canceling these out because they're just going to give us 1, and anything times 1 is itself. So here I'm left with 2 6's being multiplied to each other on the top, which is the same as 6 squared. So expanding it out, simplifying, and then figuring out what your answer is. That's, again, the expanded long way to do it. The shortcut is to use what we call the quotient of powers property, which is when you're dividing two exponential expressions with the same base, you subtract the exponents. So again, I'm going to show you how you can do that as a shortcut. You write it as your division problem here, and instead of adding like we did when we multiplied, we're going to be subtracting these exponents. So I'm going to have 6 to the 5th power minus the 3rd power, which gives me 6 squared. So again, this is kind of the shortcut by using your quotient of powers property. All right, and those are the 4 that we're going to learn today. We're going to make a foldable coming up that will organize all of these so that you guys can get more practice with them and have them as a resource for you in your notebooks. All right, thank you.